Hello, I'm going to go through a question which is to do with derivatives and finding minimum and maximum values, optimal values using derivatives. Here we have a question which says a rectangular block is such that its sides of its base are of length x and 3x. So a rectangular box, the base is x and 3x, that's the base. And we have to have some sort of height, which we're not familiar with at the moment. We'll just put h. All right, just put h. Now, the sum of its lengths of all of its edges is 20. All right, the rectangular block, the base. Rectangular block is such that the sides of its base are lengths x and 3x, and the sum, okay, so h, the x, there's 1, 2, 3, 4 of those. 3x, there's 1, 2, 3, 4 of those. And there's this height, which we don't know. And there's 4 of those. 1, 2, 3, 4. That's it. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Okay, that's all the 12 edges. And the sum of those edges equals 20. Well, let's simplify this. If we divide everything by 4, we'll get x plus 3x plus h equals 5. And we need to know what h is, and that's 5 minus 4x, because 3x plus x is 4x, and we'll take that across to be 4x. So we know now that h is 5 minus 4x. Well, that was easy. Show that the volume is length times width times height. The length is x, the width is 3x, and the height is 5 minus 4x. That was a bit of a tricky maneuver to work out the height. Now we needed that 5 minus 4x to find the volume, and we've got 3x squared times 5 minus 4x. And when we expand that, we get 15x squared minus 12x cubed. And that's exactly what we were looking for. Now we want dv dx. dv dx is the derivative of this equation of x. So the derivative is 30x minus 36x squared. So I'll put that up here, 30x minus 36x squared. Find the coordinates of the local maximum of the graph against x for the interval 0 to x, 0 to 1.25. Okay, well, let's get a copy of what we've done so far. All right, so we've done that so far. Let's now just take this part, and we need to sketch a graph. So I'm going to clear the whiteboard, and I'm going to put a graph paper, and let's paste that back, what we just had. And I'll just make that a little bit smaller so that we can put it somewhere in the corner. Okay. Now we asked to find the coordinates of the local maximum. All right, well, the coordinates of the local maximum is when, because it's the local maximum, at the local maximum positions, the dy dx is equal to 0 at those points. So what we have to do is solve this value to be 0. So the derivative is 30x minus 36x squared. Now we have to stay between 0 and 1.25. So we can't go smaller than 0, and we can't go bigger than 1.25. So let's solve this. 0 equals 2. 4. Let's just say 2. X is common. All right, so take 2x out. That will leave 15 minus 18x. Therefore, x is equal to 0. That's allowed. And 15 minus 18x equals 0. So 15 equals 18x. So 15 over 18 equals x. Divide by 5, divide by 3. 5/6 equal to x. We want the coordinates. Okay, so 0 something and 5/6 something. All right, substitute 0 into our formula. Volume equals 0 is 0. And substitute 5/6 into our formula, 15x squared. Remember 15x squared minus 12x cubed. So minus 12 5/6 cubed equals, all right, I'm going to pick up my calculator. 15 times 5/6 to the power of 2 minus 12 times 5/6 to the power of 3. And we get error. Okay, I'll just use the other calculator. 15 times bracket fraction 5/6 5/6, close the bracket, the power of 2 minus 12 times 5/6 to the power of 3. All right, I get 3.477, 3.4722222. Okay. If x is 0 to 0.8, find the absolute maximum. All right. So now part B, x is an element. I should have said x is an element. X is an element is somewhere between 0 and 0.8. Okay, what is that? Is 0.856? What is 5/6? 83333? 0.8333. 5/6 is outside of our interval. So only 0, 0 is in that interval. Find the absolute maximum of V for which between 0 and 0.8. Well, the thing is, at 0, 0, there is a turning point. And then it's going to go up to a point. So if I just do a little bit of graph here, remember this. 0, 0, and then it's, let's say there's 1. Let's say there's 0.8. That's our range. We've got to stay in here. But at 0.833, there's a position up here where the graph was rising, but that's outside of our interval. So the absolute maximum is going to happen right here at 0.8 because there's a minimum down here at 0, 0. So what we have to do is substitute 0.8 because 0.8 is called our absolute maximum of V in that interval. So if you substitute 0.8, the function of 0.8 in V, so it's 15 times 0.8 squared minus 12 times 0.8 cubed. So 15 times 0.8 squared minus 12 times 0.8 cubed. I get 3.477. 0.456. That is the greatest value that it reaches in that interval. It doesn't, there's no other maximums in there. So the absolute maximum is 3.456. 3.456. Now, if x is from 0 to 1, find the absolute maximum. Now we can go from 0 to 1, not from 0 to 0.8, which means from 0 to 1. Now, what we want to know is this point here, was this a maximum point? Or was this a point of inflection, which means it went on to a higher value, or did it come down to a lower value? Well, let's find out by using the second derivative. The second derivative is, what have we got here? dv dx. Okay. So we write d2v dx squared, that's how you write the second derivative, is equal to 30 second derivative minus double 36, so that's 72x. Now, if you substitute 5/6 in here, at 5/6, we get 30 minus 72 times 5/6. Now, do we get a positive number or a negative number? So let me just fix this whiteboard because it's resizing on me. And what do we got? 30 minus 72 30 minus 72 times 5 divided by 6. Negative 30. We get a negative, which means it's concave down. So when the second derivative is negative, it's a concave down. So it means that this is a maximum point. And so it's going to drop lower. So if you substitute 1, you're going to get a lower value than 3.4722. So the absolute maximum in that range is 3.4722, and you won't get a bigger answer. You won't get a bigger value than 3.47222. All right. What I'd like to do now, we've answered all of this without a graph. I just want to take this formula, 15x squared minus 12x cubed, I want you to put that into the graph. And write 15x squared minus 12x cubed. I want you to sketch that. And let's just adjust the x and y. Let's call x minimum, say -1, and x maximum, say 2, because we were going basically between 0 and 1 the whole time. Y minimum to be, say, -5. And y maximum, as you remember, we didn't get much of a value higher than 4, so let's go up to 6 and we sketch this. I'm going to get a graph which goes from, say, that's 0, would that be 1, would that be 2, would that be -1, and I was going to go up to a height of 6. And what we've got is a graph that looks like and it turns at 0.833. Get the analysis here. I'll just G-solve for maximum. And we've got a 0.833, that's 0.75. So that's 0.75, 0.5, 0.833, and 3.47. 3.47 about here. And if you recall, they wanted the absolute maximum between 0 and 1, and that's the absolute maximum right there at 3.424722222222, because it happens at when x is 5/6. Therefore, the absolute maximum value in that range from 0 to 1 is 3.47222 recurring. And that was the last question we had. So during the question, we had to do derivative. To solve the derivative, we found 5/6 and 0. We found the second derivative. If you substitute the values for x, if it's a positive answer when x is 0, you get a value of 30, which is positive, which means concave up. So we call that a minimum point. So it's a minimum at x is 0. And if you substitute 5/6 in the second derivative, 30 minus 72 times 5/6, and you get a negative answer. That means it's a maximum, it's concave down, and it is. It's concave down, bowl shape down, concave up at 0, 0, concave down. Therefore, when it's concave down, it's a maximum. When it's concave up, it's a minimum. All right, I hope this has helped. Till next time, stay happy.